Thank you for coming. My name is Charlie Berger. I'm the Senior Director of Product Management for Oracle Machine Learning, and with me today I have...
My name is Brendan Tierney. I don't work for Oracle, like I'm an independent, but I've been working with the machine learning parts of the database for a very, very long time. I've written some books about it, about the Oracle machine learning and about other topics on machine learning as well. So I've been using these products for quite a while.
And so together we're going to try and talk you through what we have for an offering for machine learning, give you some examples, give you some demos, answer any questions. We got a relatively small crowd, and try to give you a little bit of guidance, because these days we have a lot of machine learning from Oracle. It's really kind of coming of age, and a lot of the questions we get is, well, when do I use what, where? And we'll try to show you those options and alternatives, and so you can help make intelligent choices there for you. I do want to say thank you for coming. It's towards the end of a very long, very, very busy week. I know everyone's tired, so I do appreciate for you guys being here. So let's get into it. That's the punchline. If you have to leave early, that's the punchline. What we do is we move the algorithms, not the data. This is an Oracle strategy. I really kind of consider most every other machine learning offering that you would use out there today. Not every one of them. Some of them do it a little bit similar to what we do, but pretty much everyone. If you use Python, by the way, are there any machine learning, lurking data science experts, intermediates or experts in this field in the room that want to declare themselves that they do this already? How many people here are more of sort of an aspirational, I want to get into machine learning a little bit more, learn a little bit more, see how I can apply it, see how easy it is to use? And how many are here just to read their email? All right, because there's no chairs out there. I was doing that in another guy's conference, another guy's talk. So let's get into it. Oh yeah, so we moved all the algorithms to the data. Why? Because you need the algorithms to learn. They need data. Where's the data? It's in a database usually. As you're here at an Oracle conference, oftentimes that data is in an Oracle database. So if you move all the algorithms to some other platform, like say Python or R or whatever, to build your models, and then you have a eureka moment, and you have this really useful model written in Python code or R or SAS from SAS Institute or SPSS, Watson, any of that kind of stuff, and you have a really good model. Well, in order to put that model to work, you have to take the logic of that model and you have to apply it to more data, right? Where's the data? Data is probably stored back, safe, secure, backed up, scalable, all that stuff in somebody's database. And if you have an Oracle database, all that happens in the same place. We converge those two worlds. We converge the security, scalability, query, BI, all that kind of world, backup, encryption, all those wonderful features that the database has accumulated over 40 years. And we add one additional feature, algorithms. And the algorithms are now part of that same platform. So when I build a model, boom, I build a model in like seconds or minutes, and I can apply the model. And if I want to take that whole methodology, that script, and I want to move it up to an autonomous transactional processing database, Brendan and I had a talk, I think it was yesterday, where we showed, Brendan showed how you could take that and deploy it through REST services and so on. So there's a lot of options, and we're going to try and give you a little bit more on that. But that's the punchline. Most what I call legacy machine learning platforms today, Python, R, those kind of things, what they do is they take the data out, they move it over to an analytical platform, they do their thing, and then you're kind of stuck. So this is what we call sort of next generation, or the more logical, I think, way to approach machine learning. Safe harbor, I'm in development. I'll probably be talking about a few things, but we always are required to put up the safe harbor statement. And in case you're in the wrong room, this is the talk that we posted on the content catalog. So hopefully this is what you came to see. Brendan and I both tweet a little bit, so if you want to follow us, and he's written a lot of different books, he puts out a lot of good content, just follow him at Brendan Tierney.
So take out your phone, go onto Twitter, follow.
Or you can't just take a picture and snap and it automatically does it or something. But he puts out a lot of good stuff, and I also tweet now and then, so get links and different kind of things. So very good ways to kind of keep up with different things. So the product offering that we're talking about is called Oracle Machine Learning. We've done a little bit of sort of sleight of hand, soft rebranding. Officially, if you look in the documentation, or officially if you look on the price list, you'll probably see something called Oracle Advanced Analytics, or Oracle R Enterprise, or Oracle Data Mining. Oracle Machine Learning Notebooks are the name of the actual notebooks that go with Autonomous. And we said, this is just too confusing. And we didn't get quite Larry approval to just change everything officially, so we just decided, like Prince, we're just going to decide to call ourselves something different, right? So we call ourselves on the website and everywhere we go Oracle Machine Learning, and as the family of Oracle Machine Learning for SQL, Oracle Machine Learning for R, Oracle Machine Learning for Python, which is coming out very soon, and I'll talk about how that integrates, Oracle Machine Learning Notebooks, which are Zeppelin notebooks, Oracle Data Miner, we kept the old way. Why? Because it's sort of the fat client on-premise, could connect up to a cloud, but it's a slightly, we didn't want to call that Oracle Machine Learning user interface because we also have another user interface called AutoML user interface that's coming up on the cloud. So we said, well, let's leave that one at the old name. And then Oracle Machine Learning for Spark. And underneath there, you can see the old names, the official names maybe that we're starting to deprecate. And then you also see the Oracle Machine Learning Microservices, which I have to update the double asterisk on that because that is not necessarily the double asterisk, it's just a single asterisk right now. It's coming soon. So that is allowing us to take our models and deploy them out on Docker containers. So we have some of the applications teams that are now saying, okay, I'm going to build the model in the Autonomous Database or the regular on-premise database, whatever, it's just the database. And once I have the model, I want to export that model out as serialized code, and I want to run it away from the database. I want to use a REST service, and what we provide there are microservices to do that. And that's a whole fascinating area just unto itself. So you can see it gets kind of confusing. I just want to ask, any quick questions so far about, well, I'm even more confused, or what about this? Or some people say, what about datascience.com? What about the adaptive intelligence applications? Oracle Analytics Cloud also has algorithms that they talk to from open source. Any confusion on any of those things? Right. Well, you're in the right spot because this is what you should be using. All right.
What about data in Elasticsearch?
I have no data in the Elasticsearch Index. I have no idea. I mean, you can use it, I suppose, to analyze it, but it has nothing to do with my product offering. I don't quite understand the question.
Can we apply the algorithms on those data that's there?
Yeah, I mean, as long as you have the data, and for us, we at the core usually are analyzing data that's in a table or a view, or several tables and views all joined together. So wherever that data is, just analyze it right there. It's amazing the things I see people trying to predict and understand. I said in one of the other talks that I ran into some people that were just trying to build a model that was trying to predict gender, which I thought was kind of silly. But it turns out it actually was a very key, important thing for them. I thought it was just some sales team trying to build a demo that was not very good. But in the banking situation, they were trying to figure out what the customer was going to be doing, and oftentimes they didn't know the gender. So based on other information, they were going to try and predict gender, and that was going to be used for downstream processing. And so if you have data and you think there's a pattern in there, you can use the algorithms to help solve a problem, hopefully. That's what it's all about. It's up to you to one of my catch positionings or whatever, and I think Brendan's too, is it doesn't have to be complicated. You don't have to have a PhD in machine learning to do this stuff. I think this is a very attainable evolutionary path for SQL and Oracle professionals to add machine learning skills to their resume, if you will, and keep going. So it's the domain expertise, knowing what the problem statement is, what you're trying to do, and what's the appropriate data to assemble to try and solve that problem. I think that's what it's all about. So to show it again, sort of in a little animation, what we've done is we've taken that algorithm on the right, which if you remember or know, that is a naive Bayes algorithm that I think was invented like in the 1600s. And what we've done is we've taught the database how to do that math. How? It's just counting, right? Count the number of times that somebody was doing, they bought a motorcycle, how many times they were a male and bought a motorcycle versus a female bought a motorcycle, how many times they are a cat lover versus a dog lover and bought a motorcycle. And we're just counting things up and finding correlations and developing conditional probabilistic models. And we added many other algorithms to the database. We exposed them via their native SQL. We expose them via R. We expose them and integrate with R. We expose them via Python very, very soon. We're just going into beta with that now, and integrate with Python. So there's a lot of different options here. And when you do this, it sort of changes everything. Right now you think, hey, wait a minute, that database that has all my data on expense reports, or all my data on purchases, or my ERP data, or my HR data, or my measurement data from the lab or whatever, while the data is in this 40-year-old data repository, a file cabinet that's storing and securing and backing up and making that data available, I've kind of thrown a calculator into that thing and kind of stem celled a bunch of equations into the database. And now that database can almost think and tackle problems and make predictions. You as the machine learning data scientist, whatever user, needs to kind of direct those algorithms to whatever task you're trying to solve. But that's almost kind of the easy part. Define a problem. Well, it's actually the hardest part, to find a very specific problem that you're trying to solve, figure out what is the data that you need to solve that, and tackle that, and then point it to the right algorithms, and the rest is somewhat automated. So in terms of algorithms, this is the, I think, mostly comprehensive list, although we keep on adding new algorithms. There are a couple of notable ones that are on their way. XGBoost, which has been a popular winner of Kaggle competitions, is joining the list here in 20C, so that'll go on autonomous. And also something called MSET2, which is a process monitoring, kind of a very very insensitive to false positives and such, and used in nuclear power plants to monitor, whether or not the process is running smoothly. So what's interesting about these algorithms, aside that they're cool, regression, classification, clustering, all these different things, they also ingest, or are capable of ingesting, the different data types that are supported by the database. So if I always joke, marital status is not single, married, divorced, but it's more like it's a CLOB, and it's a paragraph, it's an email, it's a prenuptial agreement, there's a PDF form or whatever. The Oracle database with Oracle Text knows how to parse out that document, break it up into little words, and bring in a vector of words that are also used as additional input for my predictive model as to whether or not you're likely to, I don't know, buy a hybrid car or something like that. We also have aggregation. So if you have a lot of nested transactional data, or you're the patient and you have what drugs is this patient on, I don't have to allocate a column for every single drug and have it no, but this drug over here, yes. That's not the way you store data in the database. You store it as you have Charlie Berger, and here's he was issued this opioid, another opioid, and then when I build a predictive model, I can do things like count the population average for people who have opioids. This particular patient has this number of opioids due to a derived variable that is the multiplier of those two. I have 400 times as many opioids as the regular population, and that's yet another kind of interesting variable to push into the algorithms. So there's quite an toolkit that you can use to do a lot of different things. There's also quite a few statistical functions inside the database. So if you remember your old stats classes, Pearson correlation coefficients, t-test, f-test. By the way, as people are taking pictures, and thank you, that's great if it's useful. The slides should be out there on Content Catalog. Did you check? Because I think they said they're going to push them out on Thursday. You have seen slides? Perfect, good. I was worried about that. I think they said they were going to wait until today. So that answers that question. So there's quite a few features and functions here, and this is where it starts to get a little confusing, right? So I could run those features and functions from SQL, and this is just a nice, simple statistical query that says, go into the database, figure out what the purchases are sold to men, how much is sold to women. Actually, I'd like to do a group by, so partition this by, or group this by income level, and they're stratified, buckets of income levels, and then do a two-sided p-value. And if you remember from your old stats class, a two-sided t-test that returns a value of smaller than 0.05 means it is statistically significantly different. So you see the amount that men buy, the amount that women buy, and yes, some of those are statistically significantly different. Others, there's not enough data or whatever, not enough separation to say it's really a valid finding. So you could do A/B offer testing, right? On your website, just constantly do A/B offer testing, just run the whole thing through the database. And you don't have to move the data out to something else to do those computations. The database can do that. But it gets more interesting. I could go sort of up the analytical food chain, and now I could do classification. So now I'm trying to build a predictive model that's going to classify, in this case, customers on their likelihood to buy an insurance policy. Maybe you are going to go on a cruise, and they want to know, well, who's likely to upgrade to buy the travel insurance, things like that. Or other kind of situations. So you're trying to use the historical data to build a predictive model, and then once that model is built, and the model it's just like running a query. If you run a query in the database and it brings back a result, the building of a model inside the database takes just 10-20% longer. It's not a big thing. It just runs inside the database just like any other query in the database, except it's an analytical query of sort. And then that model that you've created, the buy insurance _1, can be used right on the fly. It can be used in batch. You can do whatever you want to do to make some sort of prediction, and it returns here 0.927. And if I wanted to change those values, the checking amount is not 825. That was a typo. It's 285. Okay, run it again, and it's just score. Use a barcode reader, scan everything, get a prediction. You can do those kind of things, and so you can do that in In SQL, here's another one where we are using a different algorithm, the attribute importance algorithm, to try and say which variables here are most strongly correlated with my target field. Again, people who are going to buy insurance. And so I run another algorithm through that, and it tells me 0.2161, 0.1489 on the relative strength. Now that's not a don't read too much into the actual value. That's not so much what it's saying. It's saying the most powerful, the rank #1 variable is bank funds. That's the variable that has the strongest correlation. And if you were like Pat Sajak, you need to figure out, Pat, can I buy a vowel? Can I buy another variable? That would be the next variable you'd want to buy if you were going to try and include that in your analysis to try and build a predictive model. But if you don't speak SQL and you're a data scientist whose native tongue is R, we expose and wrap that same function to the language R, and you just run it with different syntax, calling syntax, and you get the same results, right? And you can also integrate and call out to R, and in that case, when you do that, you're taking the data and you're pushing it out into the R server, and you let the R single-threaded memory-constrained R server do all the math, which is non-optimal. But there may be some techniques that you don't see in this list of analytical library, if you will, and you still need to get your job done. Zaba Bank in Croatia is a public reference of mine where they did that. They got off of SAS. They were using 95% of their work was just using the algorithms that we had, but the last 5% was missing. So they just did most of the work in the database, and at a certain point they did a call out to a script they had written in R. So you can do that with in those cases. And if your native tongue is Python, as I said, we're coming out with that in October for beta, and let's say early spring for within the autonomous database and in the cloud on notebooks. So the notebooks I'm going to show in a second now can have we'll be able to have paragraphs that some of the paragraphs are SQL, some of the paragraphs are Python, and very soon soon thereafter some of the paragraphs can be R. What's nice about that is, with data science, it's not really best to think of data science as like I take the data, export it over to a data scientist that does all their work in a vacuum. They usually don't know the domain as well as everyone else. They only are using a language that's not sort of mainstream for productionizing it. And here you can let everyone sort of work together with their most comfortable native tongue, and it's all in a collaborative environment where they can add paragraphs, edit paragraphs. They all share the same notebooks, and they can solve problems more efficiently. So overall, you can think of us as having a database that's richly enriched with many algorithms that are capable of doing many different types of things, and you have many different choices whether or not you want to use the SQL Developer. How many people use SQL Developer? So how many people know about the drag and drop GUI that's part of SQL Developer? Anybody? That's what I get for a reaction all the time. Just go to the menu, and on the top menu it says, what is it, view, something like that, view data miner. It's right there, and you do have to configure it and set it up, but then you get this drag and drop workflow. And if you follow any of the links that I showed before, there's tutorials and different things on how to do that. But the key thing back here, I guess, is that if you can do all this, you're on your way to start building applications, right? Because you're not just limited to the point of view of a data scientist. You're now able to have the data scientist productionize his or her work. So again, it keeps on getting more and more complicated, because with these different user interfaces, different languages, all running the same algorithms that are inside the database, and yet we have more algorithms that run outside the database as well. That's the Oracle machine learning for Spark. And these are algorithms that run outside the database. Some of those are our own inventions, like very fast logistic regression models, very fast neural networks and stuff that run out there. But also we sometimes wrap open source MLlib and put an R API that matches the kind of syntax we have for the other algorithms. So combined with big data SQL, you have a lot of choices. They are very fast when you run an algorithm. There's 640 million rows, 900 variables, and we're building a model in a minute, 2 or 3. So extremely fast. And part of this is just, I'm not moving the data. I would spend, I don't know how much time just taking the data and moving it to somewhere else to start the process in Python or R or something else. Here, I'm just using that Python or R API or the SQL API or the notebooks, and I'm just running the algorithms in place and getting much faster results. So when you do machine learning, with Oracle, you don't have to extract the data. The data stays where it is, so it saves you a lot of time. The data preparation, all the transformation you're doing, that's all just happening part of SQL and PL SQL scripts. You can use whatever user interface you want to use. The transformations are all embedded as part of your methodology. We have a lot of automatic data preparation. The model scoring is accelerated via, in Exadata, the model prediction probability is actually pushed down to the storage tier. So if you have Exadata, it uses the SmartScan technology, and you're ready to deploy. And you can repeat this methodology faster and more easily than you can imagine. It's just a very, very productive kind of environment. I'm going to do one last slide and turn it over to Brendan. And I like this slide, but I want to caution on it. This is a very, I think, thoughtful and well focused on topic area that Fern Halper did. I know Fern a little bit, and she's a very smart woman. I think she asked a very correct question. How long does it take to put a defined model into operational use? Defined model, what is that? Defined model, but what by that she means, I've already built the model. So I've taken the data out, I've brought it over here into Python, R, whatever. I have this eureka moment, I have this really great model, and the data scientist says, boy, look at this thing. I got 87% accuracy in predicting churn or fraud or whatever. This is great. And so everyone loves the model. They say, okay, put that into production. How long does it take to put that into production? Any guesses? Kind of a while is the answer, right? And so if you look at it, 3 to 5 months, 6 to 9 months, 9 months plus, which I think is another way of saying never. And that's something, if you add that up, it's like 65% of everybody. This corroborates a story, the research finding I saw the other day that says 87% of data science projects fail, big data science projects fail, and they fail to go into production. And so I scratch my head on that one and I go, what the heck is going on? And this is now my editorial comment, where it gets a little dangerous. This is not Fern's opinion. This is Charlie's opinion. Well, they must be using host products, right? Because they're taking the data out. They're doing this legacy kind of machine learning concept where they move the data back and forth. Because if they were using us, it would all just be immediate. It'd be in the same platform. And if I have a model that I've built, I can push it somewhere else and whatever. And with that, I'm going to turn it over to my colleague here.
Thank you, Charlie. So as you can see, productionalizing it or putting it into to day-to-day use into your applications, it's a little bit scary, and part of the reason for this is that, well, we have lots of different challenges there. It's not just the technology challenges, but we have challenges within our own organization and within our own different teams, from, looking at from the business and process owners. Like, they have certain ideas and certain things they want to be able to achieve, and whether that's achievable or not. And sometimes you kind of buy into a slight, the marketing message of, well, if I use this technology, I can achieve so much. And, it's like small incremental improvements. You're not going to do the big bang, but you can achieve a lot within that. And then you have the analytics teams, where sometimes they're quite siloed. They're kind of independent from everybody else because they're the special ones, right? So they're the unicorns that are off kind of working on things. So, and they don't want to necessarily integrate in with the wider IT community. And this is where we kind of sometimes have a bit of a challenge between like the DBAs and the infrastructure teams in with the data science, is that the data science will want to give me the data and I'll do everything else after that. Where if we want to kind of get it out of the lab environment and into production, to operationalize it, we do need to have that kind of easier integration. And there's also, we do need to rely a bit more on the DBAs and the data administrators, is because if we're looking at lots of different data protection laws like GDPR and lots of other ones, is that we need to be careful of how many copies of the data that we're making and where they're being stored. Is that, well, if everything just stays in the database, it becomes a much simpler kind of process, and we're a lot more compliant to all of this. But if we go through the typical kind of steps of what's required to create your project of, well, in a lot of cases in that data science team is that, we need to extract the data out. Now, if you've ever done a kind of extracting out a few million records, or even a few 100,000 records, it does take a little bit of time. Right? So, when we kind of take off, extracting that data, we might need to reshape it or join it together because of whatever different reasons. It might be coming from different tables, or, we need to create it into, like, if it was in like a pandas data frame. And then we can go along and start working at doing some feature engineering, like creating new values out of it. But again, if it's just in the database, then, I don't have to extract it. I don't have to do any extra work to join the data, because I could just use a SQL statement as a where clause, or a from, joining 2 tables or 3 tables. It's relatively simple and straightforward, and that's what the database is designed to do. And if you look at a lot of the surveys out there about data science projects, how long do they actually take? They will say like those few stages take 80% of your entire project time. So 80% of your project time up to generating and evaluating your machine learning models is just spent on extracting and integrating and processing data to get it into a format that you can use. So in another tool. So if we can just leave it where it is, use the language that we know and love, and be able to do it a lot simpler. And then we kind of get onto the bit, which is the machine learning bit, which is like, where we're using the algorithms. In a way, it's actually quite a trivial exercise. Right? It's only a few lines of code. You've already seen a few examples on the slides of how you can generate a model. It's not necessarily very hard, but the real challenge is, and this is where you kind of like the skill of the data scientist comes in, is about defining what your project is about. What do you want to be able to do? What do you want to be able to achieve? How are you going to measure it? How are you going to determine the success of it? But the other question that they need to ask is, how am I going to deploy it? So are we going to embed it into our applications? Is it going to go on the website? Is it going to go part of our back-end kind of processing of it? And that's where 87% of projects kind of fail because they don't go into that stage. Where if you're using SQL, it's just another SQL statement. Every developer can write SQL. And if you can do that, then you can integrate these machine learning models into your code very, very easily. The alternative then is we can REST enable it, so we can create a URL that will point to it as well. So if you kind of, whatever your developers, if they don't like SQL, then you can give them a REST API, and they're well used to working with that. And again, makes it a lot simpler to be able to go and deploy in your production environments. But if we look at a kind of a typical data science project, some of them kind of go as like, I've heard projects that have been going on for 2 years and haven't really achieved anything. But if you, again, have that kind of the right data scientist who can guide on what is the exact project that we're trying to do, if your data scientist is saying, we'll take your data, we'll analyze it, and then we'll do the machine learning on it and find the patterns. That's not the data scientist that you want. It's like, what is the business problem you're trying to address? What have you done before? What worked, what didn't? So that we can, rather than reinvent the wheel or reinvent everything that's been done before, then we can focus in on the different techniques that can be used to be able to address it. So we can almost go around this entire life cycle within a few weeks. Kind of like I've kind of listed out, it could be up to kind of 6 weeks to be able to do it. You could be looking, you could get it done in a week, depending on the problem you have and maybe the data set you have and how many different techniques you're going to evolve. So these aren't necessarily very long-term projects, right? And the other thing to keep in mind is to do with, sometimes, people can get a little bit caught up on, well, I've generated a model, but I need to improve it and improve it and improve it, right? And I need to get that small incremental improvement. So this is where I kind of describe it. There's the 50 Shades of Grey approach, right? 50 Shades of Grey, not the book, right? So, versus the Nike approach, or we just do it, right? Even we have some, the concept of, if it's good enough, let's put it out there and use it. So by using it, we're actually learning more. So we can actually take that additional knowledge that we have while using it to feed back into the next iteration and gradually, incrementally improve our models and how they're all kind of working on it. So this is where, everybody here in the room, you're going to go back to your boss tomorrow and you're going to go, I'm now a data scientist, give me a big pay rise, please, right? So like you do become a bit of a superhero, and it's only a little bit of extra code, a little few extra kind of concepts, as a developer. That's all you need to be able to go learn and being able to do different things on it. Do you want to do these couple of slides?
Right about this time is when I always like to ask, I kind of remember, oh yeah, can I take a picture of the audience and tweet it and say thank you for coming? Is that kind of okay? It's something I always like to do. It's sort of a tradition for me. And if there's anybody that feels uncomfortable, doesn't want to be here, I always say witness protection. I don't know if you guys want to move over or whatever, it's okay, but whatever you want to do. But if anybody just feels uncomfortable and says, please don't take a picture, I won't take a picture of it at all. So if you're okay, everybody's okay with it? All right, good. I'll take a real quick picture. I'll tweet these. I've been doing it all week. And I always say it helps. It's kind of a small audience, so as everyone's tired. It really helps if you look like you're excited and happy. So yay, thanks for coming. Thank you very much. You'll see that. Appreciate it. So now just a few quick slides on the Oracle Autonomous Database. So how many people have used the Oracle Autonomous Database? Okay, do you like it? So far so good? when I was coming up the escalator, I just signed up for another account. I mean, it was that quick and easy. And what's nice about it is all my algorithms and the notebooks and everything we have, they're all in there. I don't mean to say my algorithms like I wrote them, I'm the product manager for them, so other guys write them, but my product, all those algorithms are in there, and you can do all the stuff Brendan's talking about and more. They're just part of the Autonomous Database. We come with these, it comes with these Zeppelin-based notebooks. Why Zeppelin rather than Jupyter? Zeppelin, we felt, had better back-end interpreters to talk to different platforms, and also had more support for collaboration, multi-different kind of users. So we've stuck with Zeppelin, and it's all just hosted. The whole VMs are up in the part of the Autonomous platform, and so this is all locked down, secured, part of the whole platform that we expose to people, and you can do a lot of cool things with it. When you do it today, you're using SQL for all of your steps, and we're doing a hands-on lab. If anybody wants to follow me over, I'm going to rush over to Moscone West immediately following this, where we're going to have hopefully another packed room of 60 people or so. And we have it all set up, and you can do whatever you want with that. I was actually going to say that I was working on my other slides right over here somewhere, because you can also, see if I have it right here, you can also just go to this. I'm going to add that into my other deck. You can just go to there, and you can try out the whole hands-on lab when you get back to your hotel. Okay, so you might want to take a picture of that, take a picture of it, tweet it if you want to. It's amazing, cool stuff, because now all this stuff is free. And when you do that, you'll get into, in about another 3 or 4 minutes, climbing up 1 or 2 escalators, you can fill out this whole thing, and you'll get a link, and then you'll get access to it, and you can go use the Autonomous Database. And when you do that, you want to go down here. There are different labs. You want to go to Lab 300, and then you'll go into this whole notebooks and such. So there's a bunch of example notebooks here. Okay, there's a bunch of example notebooks for whatever you want to do. So that's what we're doing over there. You don't have to walk that far. You can just on the up or down the escalator, take out an account, and go do it then or from your hotel room. So I'm just kind of watching the clock tick by here, trying to keep this moving along. So we have a slight adjustment in the algorithms that are on the Autonomous Database. We removed the R because R has to have the ability to call out to a foreign object, and we're changing the way we approach that up on the Autonomous, where you use REST APIs, and we're going to do that integration back and forth with Python first. So Python will be on in the early spring, and then R shortly thereafter. So it's a very similar but slightly different list of algorithms. As I said before, there's a number of different examples, statistical functions, time series. If you want to do, one of the customers I had present, Ta from Fourth Smart Corporation from Thailand, I taught him how to use this stuff. I said, you're doing a classification problem. Take the classification example up there, read it, understand it, change the names of the tables, the names of the variables to the target field to yours, and off you go. And he's now a data scientist. So there is this whole demo, and it's based off that workshop, and Brendan's going to take us into that whole detail.
So what I have is a video, but slightly longer than the time that we have left, right? So what I'm going to do is I'm just going to pass by it.
We'll just play parts of it.
But because what we have is we have a few slides that kind of does the same thing. So I'll kind of talk through it. So when you go into that lab 300, this is it. All right, so you get to see what it's like, working with notebooks. It's a great way for data scientists or yourselves to be able to work on pieces of code, being able to explore it, and then you can start sharing it with other people within your team or your managers, and they can run it or they can view the results that are there in it. So as we kind of go through it, we can start doing lots of different things. So as you can see here, we have different cells where we can start putting in our code. It's just straightforward SQL kind of statements on it. But one of the cool things it comes with is graphics, right? We can now, we don't have to do any special coding or anything like that. We can take that code and, take whether we want a bar chart, a pie chart, a histogram, a trend, or a scatter plot. It's pretty much most of what you would want to do in order to be able to explore your data. So if we go back to those steps of, what is the typical steps you go through is, well, does the data extraction, the data integration, or kind of merging of it, and then we get into exploring our data. Because the data is in the database, I don't have to do those extra few steps, right? I'm straight into exploring the data, so I can start building up a picture and a better understanding of what is going on. And for this particular case, we're trying to work out people's credit score. So we can see that, well, there's a certain percentage of people have good, and we have a much higher number that have a mixture of other different types of credit scores. So this is a way of allowing us to be able to go and explore it in a few different ways. And then we can get a bit more sophisticated with our charts by going like, well, we can start stacking them up and we can start grouping them. So this is where we start seeing, well, there's certain distributions of the data across these. So if we kind of take, in this particular case, the loan amount, we see that, well, I think it's the green is to do with higher education, or
It's labeled over there on the far right. You can barely see it.
yeah, it's for education.
I think it is, yeah.
My eyesight, I can't see it at this angle, so it's just, yeah, it's for education. So we get to see, the size of the loans versus some of the other ones. So like on the blue, it's more to do with housing, right? So you can see how that is actually distributed across and the range of values on it. And by doing this, looking at the data in slightly different ways, we start seeing maybe certain patterns in it that, we wouldn't see by just looking at the numbers. Right, so this is kind of, by visualizing it, we get to see, us as humans can see things a lot clearer and easier. And then we can represent data in different ways. And what we can do is we can also kind of parameterize some of these reports. So if we're going to be sharing it with our managers or other analysts, is that they don't have to write the code. Or if you say to them, well, you just change the where clause for whatever state or whatever particular value that you want to examine it for, is that, well, you don't have to do that, is we can parameterize it so it becomes a drop-down item on our queries, which is really cool, really interesting, and makes it much simpler and more intuitive for the people to use. But now that we've done that, we've explored the data, we can start using some of the machine learning on it. So this is one of the ones where we start looking at doing attribute importance. So out of all the variables that we have, which ones seem to be more important than others? So which ones seem to indicate a particular event is happening or not? So this is an easy way for us to look at, if we have a data set of 200 variables, is, well, which ones are the most important ones? So this can maybe bring it down to there's 10 or 12 or 15 different variables that are the most important, which again gives us more insight into what's happening, a better understanding of what's happening in our data. And we can start applying our own domain knowledge and business knowledge to be able to explain all of that. So once we've kind of gone through the process of exploring the data, getting a better understanding of it, we can start now looking at, well, is there other machine learning that I can do in it? So in this particular case, what we can start looking at is we can look at building a classification algorithm. Now, there's kind of looks like a lot of code there, but like a lot of this is to do for repeatability. So it drops some objects and then it goes creates them. So it's to allow for that repeatability in it. But the main bit is like the bits of code that are there in the boxes, where we define our data set for our training. So we take our data set with known examples, we divide it into a training data set and a test data set. Then we set up some of the parameters of it. And then down in the bottom box, we have this thing called create model, where we give it a name, we give it what's the type we're going for, and we pass in the data set. It's not necessarily very complicated to do. Like, as you can see, it's only a few lines of code, and very achievable by, pretty much all of us, as developers and all of this. And then we can get into, again, using the graphing features within Oracle Machine Learning. We can start exploring the outcomes of it and, how good the accuracy was. And if we ended up by going and creating lots of other models, we can start comparing the overall accuracy on it and being able to, again, instead of looking at just numbers, we can just chart these up without having to write any code. So if I was using like notebooks and with other languages, I would have to go and write that code to be able to produce those charts. But I don't have to do that here in machine learning. They make it even easier for us. And then, going on, taking that machine learning model, I can apply that to new data, whether that data is in a table, and we can score it, and then we can get the predicted outcome from it, right? So it's all relatively simple. So what you could see is that, well, could you take that select statement and embed it in your application? Now, it probably looks a little bit complicated. You can make it much simpler than that if you really want. So you can hand that over to your developers, and they can embed it in their applications and being able to do that predictions in real time. All right? Or if I want to do it on kind of rather than doing it in kind of on data in a table, I can do what's like, you know, real-time scoring or what-if analysis on it. So if you're there in your application or on your website, the customer's entering in their data, is that you could have this piece of code firing to, based on every value that's entered, to be able to do a prediction on whether they're actually a good customer or a bad customer, or what their credit rating should be. So again, you know, we can hand that off to the developers very easily, or we can, you know, if our schema is REST enabled, which is really easy to do, we can create a URL that will point to that piece of code that will go and fire it. And again, you know, if you're there with your Python or your JavaScript developers, they can very easily kind of call that and use that to be able to explore all the different data. The main thing is, it's still there in the database. You know, there's very little data in and out of the database. If the data's in the database, it stays there. The model's in the database, and then it's a very, very simple function call to be able to call it. Really quick, really efficient. You know, like I've done lots of different tests on, you know, how quick is this for processing several million records. I know Charlie gave a bit of an extreme example earlier on of, you know, really, really large data, but anything from, you know, a few thousand up to, you know, like 50 million records, it's done in like that. All right. Okay. Maybe not for the 50 million, but like, you know, it's still relatively, you know, very, very quick. If you're only doing small records like in your applications, you're just getting an instant reply. So it's really quick, really efficient doing it, and that makes it easy to deploy. So all of those issues about production deployment are gone. Right. So whether you're using SQL or the REST-enabled parts of it, you can now be one of those successful data science projects or machine learning projects very, very quickly, very, very efficiently.
All right.
Okay.
And then we just want to kind of close out. You might be wondering, what is this tag cloud up here? I think what I did was I took the description of Oracle Advanced Analytics on the website and put it into a tag cloud generator, and so that's how they describe themselves. And what we're doing is we're kind of morphing into the world of Oracle Analytics Cloud, saying, well, now that we as information producers, Brendan and I, have been whacking at this data and building predictions and insights, and for every variable or many variables, maybe we now have a predicted value and a probability of that predicted value. Well, there's another really good tool that comes in handy here, Oracle Analytics Cloud, or Oracle Data Visualization Desktop. So we didn't really show it, but one of the techniques we can do is a decision tree, which kind of takes a large population and keeps on splitting it down to ever more pure subpopulations, what they call leafs. You find, here's a lot of people that are likely to buy insurance, and they're of this age, gender, whatever. Here's a bunch of other people that are not likely to buy insurance because of these different reasons. And it gets kind of complicated to view. From a data science point of view, we may really like it, but show it to your manager, it's not going to be good, right? So you can just leave those results in the database and then visualize it with a different kind of way. And the descriptions of what you're doing are in there as well. So it's very easy to leave the data in the database. You as a DBA, database developer, BI analyst, can evolve your skills and add more and more machine learning very easily, collaborate with other different domain experts and different stakeholders in the whole process, leave the results there, view them, share them via Oracle Analytics Cloud, or even better, as Brendan keeps on alluding to, put them in an application. I mean, that's what it's all about, just automate the whole thing. And congratulations now, 45 minutes later, you guys are all officially Oracle data scientists. It's not that hard. Just a show of hands, how many people think this is an attainable goal, that within, you know, a few weeks, a few months, you guys could be doing this stuff? Just one, this guy. Nobody else? Okay, a few other people. I think it's very, very achievable. So if you want more information, you go to the website there. If you send an email off to my email, you'll get the links. And I do always give a commercial for this user group meeting. I'm the co-founder of this. I work with a lot of different volunteers, and then we have people like Brendan come out and present, and a bunch of different experts, customers, consultants, and it's very, very inexpensive. It's in the slides and links. With that, please fill out the survey. We ask you to do that. Thank you very, very much for your time. I think we're being told that we're done, so thank you.